This is a video on C1 Edexcel chemistry, topic 4, obtaining and using metals. So let's get stuck straight into that. Let's get my highlighter tool up. So it's talking about metal ores to begin with. Then we move on to extracting metals, what the properties of metals are, how we can alloy metals, and also the benefits of recycling metals. We need to talk about the properties of some specific metals, and that's quite important. So generally you don't find metals in the ground, okay, in pure lumps. Generally that's not the case. Instead you find them in compounds with other elements. Normally it's oxygen. If there's enough of a metal in a compound to worthwhile digging it up, it's called a metal ore. So metal ores are what we dig up to actually get a metal. So the more reactive a metal, the harder it is to extract. So more reactive means it's harder to extract. Metal oxides need oxygen removed from them before the metal is used. If oxygen is being gained from the process, it's known as oxidation. If oxygen is being lost, it's called reduction. That's a key idea over here. So all of this bit of starting from is really poorly demonstrated again. If oxygen is being gained, that's called oxidation. If oxygen is being lost, the process is called reduction. So if you want metal oxide and you want to get rid of the oxygen, that's reduction. However, if you want to add oxygen, that's oxidation. Some metals, such as gold, massively unreactive, so you find them as pure lumps. So unreactive metals, gold, platinum, and silver, generally found uncombined in pure lumps. So how do you actually extract each metal? Well, the method of extraction depends upon where it is in the series of reactivity. Anything below carbon, pretty much you can heat with carbon to extract it. Okay, so if you had iron oxide and you wanted just iron, you'd heat it with carbon to get the iron out. So excuse me. So the way that works is because the carbon is more reactive than the iron, so it takes the oxide away from the iron oxide. So iron oxide plus carbon, heat it up, you end up with iron plus carbon dioxide. So iron is taking the oxygen away because of the fact it's more reactive. Let me see if I can write that in some way. So if I've got iron oxide plus carbon, that's going to lead to, if I heated up, carbon dioxide plus iron, because the carbon is more reactive than the iron, so it takes the oxide away. That has been reduced, it's lost in oxygen. That has been oxidized, it's gaining oxygen. Okay, if you need to just go over that bit again as an example, just rewind the video and watch it there. Right. Properties of metals. So metals have typical properties. They're generally strong, which means they're hard to break. They generally can be bent or hammered into shape, which means they're malleable. And also they're good at conducting heat and electricity. There are four main there are four main metals that relate usage properties that we just need to know a bit more detail. The first one's gold. It's shiny, it's easy to shape, so it's malleable essentially. It's not very reactive, and it's good for jewellery, tooth fillings, electrical circuits. Copper is hard and strong, it's got a high melting point, it's a good conductor, so it's used for plumbing and electrical wiring. Aluminium has a low density, it's corrosion resistant. Okay. So what actually happens is pure aluminium is highly reactive, so it already is an oxide coating which you can't get rid of, so it can't corrode anymore. This makes aluminium very useful for structures like window frames, electrical cables, and aircraft. Steel, so they're alloys of iron. Okay, so different alloys of iron have different properties and therefore have different uses. So if it's very pure, it's pure iron, it's really soft, so it's too bendy. Can't really have many uses for it. Low carbon steel, so a little bit of carbon in it. You can shape it easily, so it's good for car bodies. High carbon steel, so there's lots of carbon in it. It's going to be very hard now. It's going to be inflexible. So that's blades for tools and bridges. Stainless steel, so that's where you've added chromium and nickel to it. It's rust resistant. It will not rust. Okay, so it's very useful for cutlery. So how come these things are getting harder if you're adding different atoms to them? Well, that's because we're alloying them. And if you alloy something, you're adding two different metals metals or non-metals together. So a metal is you're adding a metal to it or non-metal to it. So an alloy is a mixture of a metal with non-metals or other metals. Pure substances are too soft, so they are alloyed to allow them to be useful. Pure iron is very soft because the regular arrangement of atoms allow the layers to slide over each other easily. So you can see regular arrangement of atoms over there, so they slide over each other really easily. Think of these lined up as two peas. If it's push, they could slide over each other really easily. Alloys are harder than pure metals because the arrangement of atoms is not as regular as in a pure metal. It's not a regular arrangement anymore. When the layers try to slide over each other, they won't. Okay, so that leads to alloys generally being hard. So you can see these small sized atoms over here, they get in the way so the layers can't slide, and there's no regular pattern anymore as well. Think of that as a bunch of 2p's and 5p's in between, blocking the path, allowing them to slide over each other. Gold is generally used in jewellery as pure gold. Gold alloys, sorry, are used in jewellery because pure gold is too soft. So normally add zinc and copper and metal to it to harden it. So the carats, or the fineness, is what actually describes the proportion of pure gold there is an alloy. So pure gold is 24 carat. So 12 carat is 12 parts out of 14 are pure gold. So 12 carat gold is 50% pure gold. Sorry, excuse me. So, smart alloys. Nitinol is a smart alloy. Okay, it's nickel and titanium put together. So smart alloys have shape memory, so they always remember their original shape. So if a wire of smart alloy is bent, it returns to its original shape under heating. So it's useful for like glasses frames, so they can bend that shape and people can then sort of heat them and put them back. Not a lot of heat, just like in a cup of hot water, it will go back to its normal shape. There's loads of uses for these always being created, but one of the more recent ones is they've made stents or tubes that they actually have been created for use in damaged blood vessels to make sure the blood can continue to flow and the body can continue to function. Recycling metals is also quite important. It is important that materials, especially metals, are recycled. The main benefits is it uses less of the original, I should say, so resource. It uses less energy and it uses less money. It also makes less landfill and less rubbish. However, recycling does cost. It's not free. You have to transport this somewhere, you have to sort it, you have to process it. But if this recycling didn't take place and we mined more of the metal, that's going to eventually lead to that metal running out, but also it has environmental implications in terms of the release of CO2 and other gases. That is the end of topic 4 of C1 GCSE Chemistry for Edexcel.